Neighbors are 6 and 3. Why? Because if our index value is 2, then what are the index values of the neighbors? The left neighbor is what? What's his index value? It's 1 less, obviously, right?
Yeah, 1.
So I'm going to call that left underscore I. And then right well, not left underscore 1, left underscore I. And the right index is what? The one to the other side of the index.
Or 0. Yeah. 3.
It's weird that it matches the value. 0, 1, 2, 3. Okay. So then the value of the right one, left underscore value, is equal to array at that position. And then the value of the right one is equal to the array at the right index. That's well and good. What if they type in, I'm just going to copy all this, but I'm going to delete a few of the things. What if they say that the index is 2? Then what are the left index and the right index values? Wait, that's what we just did. What if the index was 4? What is the left index and what's the right index? 3 and 5, did I hear somebody say?
Yeah.
If so, you're correct. And what are those values at the 3 and the 5 index?
3 is 3.
0, 1, 2, 3, 4. There is no 5. So 3 is there and kaboom is there. So what could we do to fix this program? Did I really call it a program? Program.
Add if statements comparing the index they're wanting to see versus the length.
And making sure that it's not past the length or not under 0. That is a very plausible and good way of handling it. Is there another way we could do it? I wouldn't even recommend it necessarily, but we could say that the neighbors of that element are that one and that one, like wrap around. You're playing an old school video game, you walk off one side of the map and you come back to the other one. And the neighbors for that one are that one and that one. So let's write this as a program and then implement one or both of those fixes. Except to make it slightly more interesting, let's fill it full of random data. So we're going to need an array final int a size is equal to 10, whatever. And then int array is equal to, let's give it a name, array is equal to new int of that size. Why do that when we can just call dot length? Well, when you're writing algorithms, I find it sometimes easier to read if you can just say 0 and ace in size. But dot length is quite correct. Alrighty. We're going to need a random object. So random RND is equal to new random. Let's just declare everything we're going to need right off the bat. We're going to need a scanner object. Scanner SC is equal to new scanner. System.in tucked away in there. Both of those we need to add imports for. Now we're ready to run through that array, assigning random values, and a for each loop is a spectacularly bad way of doing that. Did we talk about why? Have we talked about for each loops yet with regards to arrays? I saw one person nod.
We did go through an example of one, yeah.
Okay, so you could print out an array with a for each loop, in which case it looks something like this. For every I in the array, print out the array, right? But we can't modify the values inside the array because I is just a copy of the contents. So that's bad. Instead, we'll have to use a for loop. For int I is equal to 0, I is less than the length. We could use array.length, or we could use asize. Asize is easier to type, fewer characters. I++. And then the array at that element, let's give it a random number between whatever and whatever, 0 and 99. So I'm going to put 100 there. Now let's print out our array. Let's be totally lazy and just print it out with arrays.toString rather than writing a for loop. Really? Can I be that lazy? No, let's do it the right way. For every element, for every int I that's in array, system.out.print that value plus a tab or a space. If we do tabs, it may go over too far off the screen, but I'm going to try it anyways. And then after the for loop is over, let's print out print line, just to get it to go to the next line, since print was not going to the next line. Now let's see if that portion of the code works before we do anything else. Yeah, but our array scrolled off the side. It looks like
Mine didn't.
my font's larger than yours. There we go. You know, I could shrink it down. Okay, cool. I'm happy enough with that. You saw how we used for each. The text calls it a slightly different word, and I forget what. They don't use the word each. Okie doke. Now let's enter a loop. And we're going to ask them which element they want to add the neighbors of. I'm just going to make it a while true, and then if they type in a -1, then we're going to bail. We're going to break. So system.out.println add sum of neighbors of which index. I should tell them enter -1, but I didn't. Then I'm going to say int index is equal to sc.nextInt. Now let's calculate the left index and the right index. Int left index, left I, I'm not digging that. I'm going to use the whole word. Left underscore index is equal to index -1. And int right index equals index +1. Then let's get the left value and the right value. Int left value, L value, is equal to the array at that position, left index, int R value is equal to array the right index. Let's get the sum, add those two guys together, and just print it out. System.out.println sum of neighbors equals plus sum. And I forgot to do that if -1, then break. I guess I'll do that right after I get the input. So I'm going to have to add a line here that I forgot, which is if index is equal to -1, then break. that's my while loop. Let's run it. Once you get it working, find a fix so that it won't break if I enter 0 or 9. Let's make sure 2 works. Okay, 65. Make sure 1 works. That's 69 plus 19. Make sure 8 works. Make sure 9 crashes. Yeah, and so 0 will crash as well. So I'm going to wander around and make sure that everybody's typos are fixed. If yours are already working, fix it so that it does not break. And there's more than one way. This is really good. You're going to get me addicted to it, though.
They're good. They taste like whipped cream.
Do it on the
Alright.
typewriter front.
Alright. And right, that's something out of bounds.
Yeah, 8 should be the highest that it will accept gracefully. 9 should cause it to go completely. All right, it shows in 0.
Yeah. I know 0 does.
rnd.next int. You can't see that from the code. Like that.
I'll go really fast.
Semicolon at the end. See here, say, reached into file. Okay, just tack on one more closing brace. There we go. Now give it a shot. Yeah, run it. Let's get the neighbors of element number 1. So element 1 is that one. So I added 1 and 19. We got, or is that an 18? I can't read. 13. So that should be 14.
There's 2.
Okay, something typed in pinky. Let's see here. Oh, plus sign.
Oh. Yeah, it worked.
Good. So run it again and see what happens if you enter an
Is this
index
2
value of
supposed-
0.
Is 2 supposed to be 97? Because 1 is 13.
Okay, okay. So try 0 and it'll go kablooey.
Okay.
Because it's trying to add that one up with this mythical non-existent one off the other
Gotcha.
side. So look at your code, and I'm gonna do this up here, but see if you can spot
What?
what's causing the problem. And I'll give you a hint. It's that line right there, because we're giving it a
Left
left index
index,
of
but there
negative
is none.
1. Right, and so maybe an if statement, maybe something could help us there. That is a cool watch. Is that a pebble or what is that?
It's the Gear S3 Frontier.
Oh, cool.
How much was it?
$350.
That's not bad. It was a lot.
Who's got it working yet? I don't want to rush y'all. Give you the answer before you. Okay. Did you do it with if statements?
Yeah,
Okay.
and I'm adding in a message right now, that way people know why it's, I'm like just like, and I'm done,
That's cool.
so.
one way you could do it is with an if statement. If index is equal to 0, you modify the left index appropriately. And if the index is 9, you modify the right index appropriately. You can also do it mathematically with good old modulus.
Oh, I forgot we knew the array was size 10. I was wondering if it was anything.
Yeah. So what we could do is now take a look at that. That only solves it for 0. It doesn't solve it for 9. But take a look at that and see if you can figure out why it actually solves the problem.
Because 10 doesn't use a remainder.
Yeah, if our index, if the left index winds up being -1, then -1 plus 10 is what? 9. Why modulus it by 10? Just have it. It's not necessary in this case because it would never be larger than 10 on that side. But what if they typed in 9? And so our neighbors, now, according to these rules, the left index would never be large enough to cause a problem. But as we demonstrated on yours, if they type in garbage data, you can still generate an exception. What about doing the same thing to the right side? Right index is equal to right index plus 10 modulus 10. Does that do us any good? Okay, if they type in 9, then the right index becomes 10. And so what does this change it to? So 10 plus 10 is 20, modulus 10 takes it back down to 0 because 10 goes into 20 evenly with no remainder. So why did I format it like that? Because you could put that as a function. And it would handle any input without causing an error, without causing an exception. What I mean by that is, what if they typed in 20? What are the neighbors of 20? They're 19 and 21. Well, that's great and all, but it's past the end of the array. But if you mod it by the length of the array, then it brings it down to be within the length of the array. And I'm wondering about the necessity of adding this plus 10 at all. I guess that's to get -1. What is mod of -1 and 10? Don't know.
Yeah, I'm blanking.
Okay.
-1 modulus 10 is 9.
Okay. So that would work too. We don't even need to add 10 to it in order for that to work. In which case, both of these numbers are superfluous. All we need to do is to take our index and mod them by 10, and that will give us a value between 0 and 9 out of it, no matter what that number is. That's a trick you can use for random number generators that don't let you pick an upper end. Some random number generators will give you like a number between 0 and the maximum size of a byte, or of an int, like 2 billion or whatever. And then you could randomize, you could mod it by 10 to get it to force it to be between 0 and 9. Or you could mod it by 6 to force it to be between 0 and 6, 0 and 5. That makes sense? The real point of this was to reinforce the idea of index values and making sure that they can't be less than something or greater than something. But I also wanted to hit the idea of using modulus to do bounds checking and wrap around. Another case of that, my mind blanked. I can't think of another case. I know I've done it and I can't remember it. But we've done the demonstration of using modulus to figure out how many dollars and how many pennies there are if you have a total number of cents. Did we do that one?
Yeah.
Okay. Our notes for February 8th are looking pretty anemic. Is that all we did, really?
We did a lot of coding that day.
The in-class assignment was huge, and then this is small. That sounds right. So remind me how we handle partially filled arrays. What is a partially filled array?
An array that's partially filled.
It's
like
an
it
array
has
that's partially
no
filled.
values. Like
Right.
I wasn't trying to be a smart owl.
No, I know you're not. It's like on one of my quizzes, I wrote, "What is a syntax error?" And one of the answers I kept coming up with, "It's an error in the syntax of the program." You know.
Right.
Great. Okay. But anyways, it's when you have an array and you don't know how many elements in it are valid, starting from 0. That's the other use for modulus, is implementing something known as a ring buffer. Do we care? No, never mind. Copying an array. Did we do copying? Two ways you could do a copy of an array. One is you could be lazy and rely on the Java Arrays class to do it for you. Or we can roll our sleeves up and do it by hand, and we need to know how to do that. So, either in your same code or starting a new project. Heck, let's do it in the same code. After they enter -1, we're tired of playing with it, but we're going to copy the array. So we need to allocate a new array to the same size as the old one. Int new a for new array is equal to new int, and I'm going to start coding it correctly rather than using that a size thing. So what should I put here? We want it to be the length of the original array, which we called array. So array dot length. Yeah. But now we need to iterate through it, copying all the values into the new values. And this is a case where for each is not good because we don't have an index number if we're using for each. So we're just going to use a for loop. For int I is equal to 0, I is less than the length of the original array or the new one. It doesn't matter. They're the same length. And then set the new array at that specific element equal to the original array at that element. And then let's just print that out. System.out.println new a equals plus arrays.toString the new array. It seemed to work. It made a copy of it. Here's a dummy question. If you have two variables like this, how do I swap those two values? If I want C to equal 9 and B to equal 4 by the time we're done without actually coding those numbers in, what could I do to swap them?
Like an extra variable that you set one in.
Yeah, you need a third variable. And if you Google up how to swap two variables, they'll show you some horribly complex mathematical way of doing it without the third variable, and I think that's an absurd idea. So int temp is equal to one of them, doesn't matter which, And then that one, now that it's tucked away safely in temp, it's like we put it aside, we put it in the attic so we can bring the other one into its place. And then we can take that value down from the attic and put it back in the other spot. Could we modify this loop right here to reverse the array? So that element 0 goes into 9, element 1 of the original array goes into 8, element 2 goes into 7, and so on.
So in I equals array.length I greater than 0 I minus minus.
Yeah, we're going to either have to keep track of two counters, one going from 0 to 9 and one going from 9 to 0, or you can just say 9 minus I, because that would get you the same effect. So 9 minus I is equal to element I. I didn't bother modifying this. It would have worked just as well as what you said if we'd done that. How much caffeine is in this thing? Am I going to be really wired? Oh, really?
You put expressive in it.
System.
Oh, they might have actually.
System.out.println reverse equals plus
There's so much sugar though, it'll probably mess you up.
arrays dot toString of new array. Excuse me. Okay, that looks reversed. How do you run through the array looking for the maximum value? I think that was part of the homework, and we may have done a demonstration on it. Yeah, it's our in-class assignment. But if I want to rip through this array trying to find the maximum value so that when it's all done I can print out the maximum value, what am I going to do?
Set it equal to index 0 and raise it every time. Set it
Every
put
time
greater
it
than
finds
I
a
and
higher
set it
one.
to-
Right. And vice versa, reverse if you're looking for the lowest value. The only problem with that technique is it fails if the array is of length 0, but I consider that not a problem. To be strictly correct, you should initialize it with some value that would indicate that the array was of length 0, like negative infinity or the integer dot max value or something. Anyways, okay. That's how you copy the array. There's another way to copy the array. Use the arrays class. There's actually several different ways of copying the array, but the arrays class is perhaps the most elegant. Let's make a new array. I'm just going to call it BA for the B array. It's equal to arrays dot copy of, and you pass in the original array. Oh, and it blows up. What have I done wrong?
Is that the right copy?
Capital O? No.
It should be capital. Copy by.
Does it need a range? Mine corrected it to array, comma, and then another integer.
I guess I need a new. I thought you could get away with not specifying the range. Apparently that's a lie. Okay, so you have to specify the range as well, or at least the upper limit of the range. which is a nice feature to have. You know, if you only want to copy elements 10 through 20 of it, you could specify the 10 and the 20. But we could either put in size A or array.length there. And that should compile. Alrighty, now some thought problems. You don't have to type this. Okay, handling an append into an array, if we wanted to write an append method, is not terribly hard as long as we have a pointer to the last element. Say we have a counter that tells us how many we've added, and so far we've added 4. Or we've added 5, and 5 is the next 0, 1, 2, 3, 4. 4, we're going to say that 4. Our counter, our last filled one. Now I'm going to go back to 5. We've added 5 items to it. We want to append 1 to it. That's pretty easy. We just check to see if we've exceeded the length yet. The length of the array is 6. We have not exceeded it yet, so we could add 1 to that area, to that item. And then counter would become 6. Now there is no an array append function, but we could write our own if we so wanted to. Right, so let's say that we appended a z to it. Our counter becomes 6. We have a completely filled array. The next time we try to append something, it would check. Unfortunately, our counter matches the length of the array, so the array is plumb full. We'd have to print an error message or something. All well and good. Now what if we undid that and we were trying to do some kind of sorted insert? We wanted to insert B into here. Insertions in general are a real pain. How do we stick B into an array in its right place? What would we have to do to the rest of this data? It all have to be moved over like that, which is real easy to type. Not so easy to do. So what you got to do is you got to find where it should be inserted and then do a copy that moves all the elements into the element past it, and then you have room for it. That can be pretty expensive. You know, if this was an array of 10,000 items and you wanted to insert something into element 3, you might have to do 10,000 copies. There are better data structures for handling arrays type lists than the array. Arrays are perfect when you know the size of the data, you know the maximum size of the data, you're not going to be trying to append past it. What if we did want to allow appending past the end of the data? What if we did want to be able to do that? How would we do that? You would have to allocate a new array that was larger than the old array, then copy all the old array into the new array, then set the new item and update your counters. Again, you know, if you have 10,000 and you're trying to add one element to it, it's going to have to create an array that's 10,001, or maybe you give it some extra space, 100 more to fill up or something. That's not really tenable. So the advantages of an array: very fast. They're all in contiguous RAM. The bytes are all contiguous, so if you write a loop to run through it, it runs very, very quickly. And conceptually simple. The disadvantages: they are fixed in length. Inserting is a real drag. Appending is a problem once you exceed the length because it's fixed. How about deletions? Deletions are just as hard. What if I wanted to get rid of that G? What would I have to do? I'd have to copy everything over. I'd have to move to the right place and start a copy function that would shift everything to the right. So deletions are a problem. Can I type? Deletions are a problem. Solvable, but a problem. So those are the disadvantages. There's a better structure than the array for handling this kind of stuff. And there's more than one structure for doing this. But one is called the ArrayList. An ArrayList is not fixed in length. It starts off 0 in length. And then as you start adding items to it, it grows. If you delete things from it, you can specify which value you're deleting and it shrinks. If you want to sort the array, you can do that with a single call, I believe. If you want to search for an item in the array, you can do that with a single call. Some of that functionality is tucked away inside the arrays class. Arrays is a helper for dealing with a normal array. But in ArrayList, all that functionality is built right into the class. So we're going to define an array of ints. Excuse me, an array list. ArrayList. Now the declaration for an array looks something like this. We've done it already. You don't have to type this. Int, whatever, array name is equal to new int, and then you specify a length, right? This is going to be ArrayList. I'm going to call it L, or A capital L for ArrayList. But I have to specify what type of data is being stored in the array. Integer, like that, is equal to new ArrayList integer, and then the size of it. But I'm not going to specify a size. If you don't specify a size, it starts off as 0 and then starts growing. Now I get an error because this is a class that's not imported, so I'm going to click on the add import message, get that error to go away. The syntax is a little bit different, but it's not too different. There's one cleanup you can do on it. You see this word integer, it appears twice. You don't have to have it the second time. You could just do this. Delete that second word integer, because it assumes that if you declare an array of integers, then when you make a new one, it's going to be full of integers. So ArrayList is a class. It's not a primitive data structure. And the ArrayList, for it to work, needs reference types. It needs classes. It needs objects rather than primitive types like int and long. So to use ints, instead you have to use a wrapper class, integer with a capital I. To use an ArrayList of doubles, you have to use a wrapper class, double with a capital D, or long with a capital L. So that's a comment worth noting. ArrayLists must use reference types, which means classes. So rather than int, use integer. Rather than double, use double with a capital D. We be just about out of time, but let's go ahead and add some data to our array. al.add, let's add some numbers. 3, al.add 5, al.add 7. Now let's add an item to the beginning of the array. Let's insert an item into the beginning of the array. We still use add, we just specify an index value. 0, comma, we're going to stick our 9 right there at the beginning of the array. Now let's pull some values out of the array. Instead of using that square brace notation, int w is equal to al.get item 0. Index is equal to AL dot get item 1. Y is equal to AL dot get 2. And so on. Let's print the array out. System.out.println. Now, since an array list is a class, it has a toString method. We ought to just be able to do this. Okay. So hopefully you see that this last add here made 9 the new beginning of the array. So if you call add without specifying a position, it tacks it onto the end, like it did with 3, 5, and 7. But if you do specify a position, it deletes it. Let's delete one of those values. AL dot remove. I want you to remove object number 2. So which one's object number 2? Well, 0 is 9, 1 is 3, so that's going to take the 5 out of the list. All right, that's enough of this. Okay, the single dimensional assignment was due today? Yesterday? I'm just going to extend that because I haven't thought of good assignment. Well, that's not true. We can come up with an assignment using ArrayLists. Write an application that prompts the user for numbers or -1 to quit. Add each number they add to an array list. After they enter -1, print the array out. Real simple, but we're going to add on to it next week.